Find the mistake in the following proof that for all sets A and B, A minus B union A intersection B is a subset of A. Now, I haven't seen this proof yet, so we're going to discover the mistake together. And so I'm going to analyze this how I would normally analyze a student's response. So suppose A and B are any sets. Okay, that's good. And suppose X is an element of A minus B union A intersection B. Now, that's exactly what I would do in the start of this proof. I would start with an arbitrary element of this first set, and I would try to prove that that element is therefore in A. So far up to this point, we're good. If X is an element of A, then X is an element of A minus B. And so by definition of difference, X is an element of A and X is not an element of B. Now, I will say if X is an element of A minus B, by definition of difference, X is an element of A and X is not an element of B. That's correct, but there are a couple issues with this proof up to this point. Number one, we're saying if X is an element of A, but we shouldn't be making any if-then statements where X is an element of A is the if part because we want it to be the then part. So who cares what happens if X is an element of A? We're trying to justify this. Moreover, this isn't even true. If X is an element of A, then X is an element of A minus B. That's definitely not true. It could be the fact that X is in A and X is in B, which would mean that X is not an element of A minus B. And so this is flawed. But keep in mind that everything that follows from this if-then statement hinges upon the assumption that X is an element of A, which is something that we're trying to show. Now, by the definition of difference, X is an element of A and X is not an element of B. In particular, X is an element of A. This would be concluded if X were an element of A minus B, but we've never justified why X is an element of A minus B. And this is not a justification, again, for two reasons. Number one, we never showed that X is an element of A. And number two, this is not what X is an element of A means. To be an A minus B means that X is an element of A and X is not an element of B. We're missing that part still. So the conclusion here hinges upon the assumption that's the same as the conclusion, which is circular reasoning. So if X is an element of A, then X is an element of A. So there are two main critical issues in this proof. Number one, it's circular reasoning. And number two, it is not true that if X is an element of A, then X is an element of A minus B. Anyways, thanks everyone, and I'll see you in the next video.